The speed of a traveling wave. The equation of the traveling wave is given as y x comma t is equal to a sine kx minus omega t. As you can see, kx minus omega t is constant because this is basically the angle. So we can write kx minus omega t is equal to constant because the angle is constant, and we have a sine of an angle which is basically a constant too. So kx minus omega t is equal to constant. Now differentiating both sides with respect to t, and if we do that, we will write dy dt of kx minus omega t is equal to dy dt of constant. Now let's distribute d over dt inside the bracket, and if we distribute, we will write k dy dt of x because k is a constant, so we should take k out, minus omega is again a constant, so omega will be out, and then we have d over dt of t is equal to 0 because dy dt of constant is equals to 0. Now dy dt of x is basically dx over dt, and dy dt of t is 1, so we can write k dx over dt minus omega times 1 is equal to 0. If we simplify further, we can write k dx over dt minus omega is equal to 0 because omega times 1 is equal to omega. Now what we need to do, we need to take omega on the other side, and if we do that, we will write k dx over dt is equal to omega. So we have k dx over dt is equal to omega. Now I need to keep my dx over dt by itself, so I need to take this k to the other side, and if we do that, we will write dx over dt is equal to omega over k. Now we know that dx over dt is v, so we will write velocity v is equal to omega over k, and let this is our equation number 1. We know that lambda is equal to 2 pi over k, so we can write k is equal to 2 pi over lambda, where lambda is the wavelength and k is the angular wave number, and let this is our equation number 2. Now we know that omega is equal to 2 pi over t, and let this is our equation number 3, where t is the time period and omega is the angular frequency. Now let's substitute the value of k and omega into the first equation, so we can write, substituting the value of k and omega in equation 1, we can write velocity v is equal to omega over k, and for omega we are substituting 2 pi over t, and for k we are substituting 2 pi over lambda. And as we can see, 2 pi is in numerator, so we can cancel that out from both the numerators, and then we will have velocity v is equal to lambda over t. So v is equal to lambda over t, and let this is our equation number 4. Now let's write the simplified form of velocity, and if we do that, we will write velocity is equal to lambda inside the bracket 1 over t, because lambda over t can be written as lambda times 1 over t, and we know that n is equal to 1 over lambda because frequency is equal to 1 over time period. So let's substitute that value over here, and if we do that, we will write velocity is equal to wavelength times n, which is frequency. So the velocity is equal to the product of wavelength and frequency, and let this is our equation number 5. Now what we are going to do, we are going to combine equation 1, 2, 3 and 4, and if we do that, then we will write v is equal to omega over k, and the same velocity is equal to lambda over t, and that is also equal to lambda times n, where omega is the angular frequency, k is angular wave number, lambda is the wavelength, t is the time period, and n is the frequency of the wave.